All right, today we're going to talk a little bit about direct and inverse variations. Okay, so let's look at problem number 1. We're just going to do the problems on this page and then we're going to talk about them in general. But let's do some specific problems so we have some general problems to talk about. Okay, so let's start with number 1. A square with a side length x unit has a perimeter of y units. How do we set up an equation for that? So x plus x plus x plus x. Is there an easier way to say that? 4x. Okay. So just 4x for my equation? Oh, if it's an equation, it's got to equal something, right? We want it to equal y because it says the perimeter is y. So y equals 4x. You okay with that? Then it gives us a table to fill in. Where do these values come from? I don't know either. They just gave it to us. Okay. Basically, I think they gave it to us to say, do we know what to do with it? Hopefully we do, right? If x is 3, what is y? 12. If x is 7.5, what is y? And how are you getting those numbers? Multiplying it by 4, right? If x is 9.5, what is y? 38. Any questions so far? Okay. What about number 2? A rectangle with a length of x units and a width of y units has an area of 60 units. How do you find area again? Length times width, side times side. So xy equals 60. Now, is that an equation? It is, right? Something equals something. Is it typically the equations we're used to? What equations are we used to? Y equals, right? Or something equals y. So if we're going to set it up as y equals, what would it be? 60 over x. To get rid of the x on the left-hand side, we divide it. Since it's multiplying by y, we divide both sides by x. Any questions about that? Okay. If x equals 4, what is y? 15. If x equals 8, what is y? 7.5. If x equals 12, what is y? Are you doing all of these in your head? Good. If you couldn't do all these in your head really fast, could you use a calculator? Yes. Could you use the table in the calculator? Like in the graph function? Could you? For this one you could, right? Could you for this one? 7.5 in the table? 9.5 is in the table? Unless you adjusted your table, right? To count it by 5s. But it would just be easier to just punch in a calculator 60 divided by 15. Divided by 4, right? Okay. Everybody understand that? Okay. A man 5 feet tall casts a 3-foot shadow. At the same time of day, a tree y feet high casts an x feet shadow. What do you think? No, it is. How did you get there? Some people do it by setting up a proportion, right? Aren't these similar triangles? Yeah? Okay, so if I set up a proportion, there's 4 different ways I can do it. All 4 of them are correct. Okay? So do you care which way I do it? So if I said y over x, what would that equal? Y is at 5 over 3. Yeah, I did tall part over short part of the tree. So I need to do tall part over short part of the man. Right? Is that an equation? Yes. Is it an equation we're used to? Which one are we used to? 5 over 3x, which is what you said, right? Okay. So, if x equals 4.5, what is y? Thanks. We have to use our calculator for that one because it has a fraction in it or what? Oh, it has a 3? Okay. Okay. So now we're all hurriedly getting our calculators out, except you're all being really slow about it? Okay. You can't do that on your phone? You can't do 5 divided by 3 and then times 4.5? 7.5. What about if x is 9? Oh, yeah, we wouldn't even have to use our calculator for that, would we? Why can you just double that one? Why can you just double it? X is doubled, so the y is doubled? Will it do that on every table? No. Specifically on this one, it worked. We'll talk about y in a minute. 17.5. Thank you. I have a problem with this next question, but we're going to go ahead and do the math. Okay, we're going to do the math. Literally, when are you ever going to be in a situation where you're standing there and looking at a mirror to look up a certain height against the wall instead of just looking at the wall? Okay, I'm sorry. Maybe there's a half wall right here and you can't see through it. Again, what situation is it happening? Anyways, it fits with the math, so we'll just go with it, okay? A person 60 inches tall, so this distance right here is 60 inches, can look through a mirror 30 inches from the wall. So the mirror is on the floor. If she's X inches away, how far Y up the wall can she see? And literally, if you can think of a real situation where this would happen, I would love to hear it for real. Okay? So, do you think I should set up a proportion again? You can? Okay, what do you want it to look like? 60 over x equals y over 30. Is that an equation? Yes. Is it what we're used to? What do we need? I could multiply by both sides by 30. I could cross multiply and then divide both sides by x. Either one will get me the same place, right? Either one will get me to this place. Because if I cross multiply, I get xy equal 1800. Dividing both sides by x gives me 1800 over x. If I multiply both sides by 30, I get straight to 1800 over x. Any questions about that? Okay. What if x is 20? What's 1800 divided by 20? 90. 40? If x is 40? Well, wait, why didn't we just double this one? It worked over there. Oh, it doesn't work that way in this one? Okay. 45. If x is 60? 30. Okay. Any questions? Okay. Look at number 5. X people to travel, the cost, Y in dollars, is for renting a bus at $7.50 per person. What? Okay. Y equals 7.5x. Y is the cost in renting it, and we're saying it's $7.50 per person, so I'm multiplying by x. Got it? So if x is 10, y is 75. If x is 25, y is 187.50. And then if x is 30, y is 225. Okay? We had a little discussion earlier about whether this 0 is necessary. I am talking about money. Am I talking about money in the table? No. When I pull it out and answer the question, I'm talking about money. So the 0 would be necessary there. Is it necessary in the table? Not necessarily, right? You could have it there if you wanted because you do know it's talking about money. But if you didn't put the 0 right here, that's fine. Okay? What about number 6? The bus will cost $180 to rent. If X people ride, how much will it cost per person? What'd you say? Okay, where'd you get that? Okay, I'm okay with that. Could we start here? We could, right? We could start there, and then y would be 180 over x. Could we go back to number 4 real quick? What if we did cross multiply? What would we get? We talked about it, I just didn't write it down. I want you to write it down, please. You'll see why in a moment. Everybody okay so far? So let's go talk about some generalities on the back of this page. Okay? First of all, let's just look at problems 1 through 5. We're only doing this first column together. We're just looking at problems 1 through 5. It's just in the first column. Look at the tables first of all. In problems 1 through 5, what is happening to x and what is happening to y? Both of them? Yes. If x increases, then y increases. What if we're just looking at the relationship between x and y? Kind of like we're looking at the equation, but more the relationship in general besides just the equation. X and y have a constant, what? What did you call it in eighth grade when you were doing algebra 1 or whenever you were in algebra 1? What did you call it? Remember we talked about earlier it was y equals what? Mx, just mx. What did we call the m? The slope, right? We called it the slope. It has a common slope, but we're talking more about direct variation and not really like that kind of terminology. So would you be okay if we called it a common or a constant rate? Oh, in fact, didn't you call it a rate? Didn't you call it a rate of change? Isn't slope and rate of change the same? Right? So x and y do have a constant rate. Another thing that sometimes people call it is a constant ratio. Okay? Okay with that? Okay. What does the equation look like for all of these? Y equals something x, right? Okay, we're going to call it y equals kx. We could call it y equals mx, right? But we don't want to use the m for the next problem, so we'll just call it k for a constant. Something constant. In this particular case, it's a constant rate. Okay? The name of this variation is direct variation. When you look at the problem, when you look at the homework problems, the problems on the quizzes, the problems on the tests, it's going to say if y varies, how are you going to know that it's direct variation? What's it going to say in the problem? Directly. You don't have to worry about it. It's going to tell you. If y varies directly as x, and y equals 12 and x equals 8, then what is y when x equals 24? So if it tells you an x and a y, what don't you know? K. So the first thing you have to do is find k. You're going to use this equation, y equals kx, and it says y equals 12 and x equals 8. Do you see that k is the only thing you don't know? How do I solve for k? Divide both sides by 8. So k equals 4. It doesn't equal 4.
Is it 1.5?
Yes, it is. We can fix it. Sometimes I just let you go to see what's happening. Trying to figure out what's happening in your brain. Now, the rest of you reacted as I expected you to. But also, I need you to realize that you reacted kindly. Nobody was like, idiot, right? You were like, no, it doesn't. Nobody was rude or disrespectful, and I appreciate that very much. Okay, that's something we've been working on, isn't it? Okay, so k equals 1.5. Now I know what k is. Now I have to go back and, before we do that, let me make sure you understand something real quick. Okay, when we solved for k, if I solve for k in this equation right here, I get k equals y over x, right? Do you see now why we say it has a constant ratio? Why that's another word that I put up here? Isn't x over y a ratio? It's a fraction, right? Isn't that a ratio? Does that make sense? Okay, so back to the problem. I found k. Now I have to go answer the question. So I have to start over. Except now I start over with this. I know what k is. I don't have to find it anymore. Now I have to answer the question that they're asking me. What is y when x equals 24? What is y when x equals 24? What is 24 times 1.5? 36. That is my answer. Does that make sense? Okay. Now let's just look at the second column. Problems 2, 4, and 6. What do they have in common? As x increases, guys, we forgot to fill in the table. I didn't even realize that. Did you already fill it in? We just moved on. We just didn't even care about it. Okay. Okay, let's fill it in real quick. If we're talking about y equals 180 over x, if x equals 8, y equals 22.5. If x equals 12, y equals 15. And if x equals 30, y equals 6. Just 6. It's okay. So, tell me again about the tables. So, if x increases, y decreases. X and y have a constant. What kind of relationship do they have? Here, and here, and here. What are they doing to each other? They have a constant product. Every single time they multiply by each other to give us the k value, right? Okay, so what does the equation look like? Okay, y equals k over x, but for every time we also wrote something else down, didn't we? Xy equals k. Are those the same? Right? They are the same, but let's have them both. And what is it called? What kind of variation is it? And how did you know that? Yeah, it says it in the title of the worksheet, right? Okay. What do you think people normally guess when they don't look at the title of the worksheet? Indirect. Okay? It's not. That's something different. It's like a direct object or an indirect object, right? Okay? So, what's it going to say in the problem? Inversely, which I believe is an adverb because it ends in ly, right? Okay. Get some cross-curricular conversations going on. Awesome. Don't tell me to stop. Weirdo. Okay. So if y varies inversely as x and y equals 12 and x equals 8, so what do I have to find first? Your k. Well, guys, which one of these equations would it be easier to use to find k? They're both the same, right? They both mean the same thing, but this one's already solved for k, so wouldn't it make more sense to use that? Yeah. K equals xy. Well, y is 12 and x is 8. What is 8 times 12? 96. So k equals 96. So I start again. This time, would it make more sense to use this because I know I'm going to be solving for y. It asks me, what is y when? So can I say y equals 96 over x? So y equals 96 over what? When x is 24, right? What is 96 divided by 24? 4. Yep. He was just answering the question way early. Okay? Questions? Then I have one for you. Earlier she said, oh, we just double it. But then when we try to do that here, it didn't work. Do you see why now? Okay, this is direct variation. This is inverse variation. X is increasing, y is increasing. X is increasing, y is decreasing. Okay, so look at the page with the homework problems on it. Okay, look at this page. Identify whether each table shows direct variation, inverse variation, or neither. So look at table number 1. What is happening with the x's and what is happening with the y's? So then there's a chance that it's inverse, right? Now, why did I say there's a chance that it's inverse? It could not be inverse because still, yes, it's increasing, yes, it's decreasing. It has to have a constant product. X times y have to equal the same thing. Well, what is x times y? What's 4 times 110? 440. What is 5 times 88? 440. What is 8 times 55? 440. So our guess is inverse because of how the numbers in the tables are acting. Or they're not really acting because they're not really alive. But you know what I'm saying, right? Okay. Behaving? Is that better? Not really. We'll just go with it. Is that okay? But we proved it by doing our multiplication and knowing that they have a constant product. So this is inverse variation. Look at number 4. They're both increasing, so it's possible that it is direct. Do they have a constant ratio? What's 13 divided by 2? What's 32.5 divided by 5? What's 65 divided by 10? So what kind of variation is this? Direct. Okay. I'm going to leave you to do 2 and 3. I will do one of 5, 6, 7, 8, 9, or 10. Which one would you like me to do? Let's do 10. Okay. So number 10 says if y varies inversely as x, well, if it varies inversely, and I know I'm going to have to be solving for k first, can I start here? Okay. It also tells me y is 16 and x is 24. If y is 16 and x is 24, what is k? $384. Now I want to go here, y equals k over x. Could I use this equation to solve everything on this side? Yes, I could. This one's already solved for y. I'm just trying to make it easier on myself. Okay? So y equals 384 over x. What is x in this problem? 27. Jacob? Jacob, it's your favorite answer. 4. Yeah, it is. No, it's not. I was just teasing about that. Yeah. Sorry. It does have a 4 in it if it makes you feel any better. 14.2 repeating. Okay. Sorry, I didn't mean to mess you up. I was just trying to tease Jacob a little bit. Can you forgive me for that? Okay, thank you. So here's my answer. Does everybody understand how to do these problems? Okay? Any questions? Peace.